Hello everyone, I'm Jonali Mendez. My topic is all about skewness. In a numerical lead form, it's a normal distribution in collection of data. Skewness refers to the distribution or ascendancy if the curve or shifted to the left or the right. It is said to be skewness. It is the reflection of the degree to which given distribution differs from the normal distribution. Skewness can be quantified. The skew and normal distribution is zero. There is a skewness skewed to the right. There's a long tail illustration the right for the data. The skew to the right is an alternative way of defining undistributed data set on the right suggests that it's as distributed positively. In this both, the mean and the median are larger than the mode. As general rule, most of the time, the average will be greater than the median with the skew to the right or data skew to the right in summary. One is always median larger than the mode. Always median larger than the mode. Much of the time, it's median greater than median.
And when we deal with data skewed to the left, the situation reverses itself. There is a long tail stretching to the left for data that is skewed to the left. An alternative way to characterize a data set skewed to the left is to suggest that it is skewed negatively. In this case, both mean and median are smaller than the mode. As a general rule, mean would be lower than the median most of the time. For a data set skewed to the left, in summary, always mean is smaller than the mode. Always median is smaller than the mode, and much of the time, mean is less than the median. So let's have the computation on how to find out the skewness. By having the coefficient of skewness using the formula, the degree of skewness can be obtained. For example, find the skewness coefficient and tell whether the distribution is normal, skewed to the right, or skewed to the left. Note that if Sk is equal to 0, the distribution is normal. And if Sk is less than 0, the distribution is skewed to the distribution on the left. And if the Sk is greater than 0, the distribution is skewed to the right. Here are the scores: 72, 81, 67, 83, 61, 75, 78, 82, 71, and 67. First, we have to find the mean. To find the mean, just add the all numbers and divide it by the total number of scores. Since there is 10, we will divide it by 10. 72 plus 81 plus 67 plus 83 plus 61 plus 75 plus 78 plus 82 plus 71 plus 67 is equals to 737, and divided by 10 is equals to 73.7. So the mean is equals to 73.7. Second, we have to find the median, the middle number. To find the median, arrange the scores from highest to lowest: 61, 67, 67, 71, 72, 75, 78, 81, 82, and 83. Since there are 10, there are two middle numbers, which is 72 and 75. Just add 72 plus 75 is equals to 147 divided by 2 is equals to 73.5. So the median is 73.5. Third, we have to find the standard deviation. Find the standard deviation of the scores 72, 81, 67, 83, 61, 75, 78, 82, 71, 67. To compute the standard deviation, we need the mean and variance. The mean is just the average of the scores, while the variance is just the average of the squares of the deviation from the mean. So let's get started. The scores are 72, 81, 67, and so on. So we will find the sum first and next get the difference of the square and the mean, simply the division of the mean. Then square the division from the mean and find the average, and to get the standard deviation you can use the formula, which is standard deviation is equal to the square root of the division of the mean over n minus 1, so that you can get the answer of the standard deviation, which is 7.38. Next, we will find the skewness using the formula, and we will distribute the mean, median, and the standard deviation. So the answer is equal to 0.08. And the last is the interpretation. Since skewness is positive, then it is skewed to the right, but the value is too small, so we can say that the distribution is almost normal. For the group data, you can still use the formula, but make sure that in getting the mean, median, and standard deviation, you will apply the concept of group data as well.
Good day everyone, I am Rafi Marquez from BP3C, and I am the discussant of kurtosis. So, let's start. What is kurtosis? Kurtosis is a measure of the combined weight of a distribution's tails relative to the center of the distribution when a set of approximately normal data is graphed via a histogram. It shows a bell peak and most data within 3 standard deviations, plus or minus, of the mean. There are 3 kinds of kurtosis. First is mesokurtic. Mesokurtic is the distributions that are moderate in breadth and curves with a medium peak height. The second one is platykurtic. Fewer values in the tails and fewer values close to the mean. The curve has a flat peak and has more dispersed scores with lighter tails. And the last one is leptokurtic. More values in the distribution tails and more values close to the mean. Sharply peaked with heavy tails. Here are the 3 graphs of kurtosis and its characteristics. The first graph is what we call the leptokurtic distributions, if Ku is greater than 3. The second one graph is what we call the mesokurtic distributions, if Ku is equal to 3. And the last one is what we call the platykurtic distributions, if Ku is less than to 3.
Kurtosis is obtained using the following formulas. Kurtosis is equal to summation times x, the class mark, minus the mean raised to the power of 4 over n, which is sample size times the square of variance. Sample: in 2, 3, 3, 4, 4, 4, 5, 5, 6. The value of mean is 4.0. The value of x is 4.0. The value of s is 1.22. The value of the summation times x, the class mark minus the mean, raised to the power of 4. And the value of the sample size times the square of variance is 19,9380. By using the formula, substitute the following values. We have 36 divided by 19,9380 equals 1.81 equals 2.0. Therefore, the distribution is parallatic.